All right, so today we're taking notes on 7.3, part 2. And it's on partial fraction decomposition, so totally different than what we've been doing in 7.1, 7.2, and part 1 of 7.3. What we're going to be doing is taking a fraction here, a rational expression, and breaking it up into two fractions though. So each of these two fractions on the right is called the partial fraction. The sum of these fractions is called the partial fraction decomposition of the rational expression on the left-hand side. One thing that I wanted to point out in the fractions on the right, this should be x minus 4 because whatever we have in here repeats for our answers. So this repeats there and there. So it's a typo. It should be x minus 4. So this slide kind of explains the math behind it, which it'll make more sense once we start doing examples. And then this slide puts into words like each step. So step number 1 is factor the denominator. Then we split the fractions for each term of the denominator. Give the numerator a, b, and c depending on how many parts we have. And then after that, you'll see it is easier to see when you explain it than it is in words. But let's do some examples. So step 1 is factor. The denominator here is already factored for us, so we don't have to factor. Step 2 is split it up. So each part of the denominator gets its own fraction.
She said it just
Okay. So I have x minus 3 in my first part and x plus 5 in the second part. And then on the top, I'm going to make a and b. So once we split it up, the next step is to multiply each partial fraction by whatever it's missing in the denominator. So our question gave us x minus 3 times x plus 5. In my first partial fraction here, I only have x minus 3, so I have to multiply the top and the bottom by x plus 5. And then in the second one, I'm missing the x minus 3, so I multiply the top and the bottom by x minus 3. So you multiply by whatever's missing. So now if you notice, my denominators are all the same. I have x minus 3 times x plus 5 here, here, and here. They're all the same. So the denominator is equal to the denominator. So what I'm going to do is set my numerators equal to each other. So down here, I have 6x plus 14 is equal to a times x plus 5 plus b times x minus 3. So all I did was take the numerator and rewrite it. Now our goal is to find what the value of a is and what the value of b is. And to do that, we have to plug in a couple numbers. So first thing we want to plug in is what makes this parenthesis equal to 0? -5, so I'm going to plug in x is equal to -5. And then I'm also going to plug in what makes the second parenthesis equal to 0. 3. So I'm going to plug in -5 and 3. So first let's plug in -5. So I have 6x plus 14 is equal to a times -5 plus 5 plus b times -5 minus 3. Oh yes, I have to plug it in on the left also. So it should be 6 times -5. And then we simplify. So 6 times -5 would be -30, and -30 plus 14, -16. What is -5 plus 5? 0, and 0 times a? 0. So this cancels, so we get rid of that a. one of your variables, A or B, will always cancel out because we're solving for one of them, so it'll always cancel. And then here we have -5 minus 3, which is -8, so -8 times B. And then we solve for B. So divide both sides by -8. So B is equal to 2. So that's part of our answer. And we do the same thing for our other x value. So we have x is equal to 3, so we plug that into all of our x's again. So it'll be 6 times 3 plus 14 is equal to A times 3 plus 5 plus B times 3 minus 3.
So we can just plug in our value for B now and solve from like back into our original equation. Couldn't we just say B equals 2?
Well, here would it matter if you plugged in 2 for B because 3 minus 3 is 0, so this cancels. So 6 times 3 is 18. 18 plus 14 is 32. So 32 is equal to 3 plus 5 is 8, so 8A, and the B cancels out. Then divide both sides by 8, so A is equal to 4. So once we find A and B, we're almost done. We have to plug that back in into our original partial fraction up at the top. But I'm just plugging in A and B. So I have 4 over x minus 3 plus 2 over x plus 5.
Could you swap the numerators?
You cannot, like you could have swapped and make x minus 5 or x plus 5 first and made it under the A. But then it would like change your value. So your answer will always have the 2 over the x plus 5. And it'll always have the 4 over the x minus 3. So be careful that you don't swap them because then it would be incorrect. So for the next example, we're doing the same thing. So it's already factored for us. I'm going to put x minus 2 on the bottom and x minus 5 on the bottom. What's next? Multiply the tops by what's missing. So I'm going to multiply the top here by x minus 5 and the top here by x minus 2. And then we just set the tops equal to each other. So I have x minus 14 is equal to A times x minus 5 plus B times x minus 2. What do I do next? So what would make this parentheses 0? What value of x? 5. So what would make this 0 would be 5. So x is going to be equal to 5. And then what would make this one 0? 2. So we plug those in. Let's start with 5. So I have 5 minus 14 is equal to A times 5 minus 5 plus B times 5 minus 2. So this one cancels. The A cancels out because 5 minus 5 is 0. 5 minus 14 is 9, negative 9. And then 5 minus 2 is 3, so 3B. Divide both sides by 3. So B equals what? Negative 3. All right, so let's do the same thing for when x is 2. So I have 2 minus 14 is equal to A times 2 minus 5 plus B times 2 minus 2. So 2 minus 14 is negative 12. 2 minus 5 is negative 3, so negative 3A. And then the B cancels out because 2 minus 2 is 0. divide both sides by -3. So a is equal to what? 4. So once we have our a and b, we plug that back in for our answer. So a is 4 over x minus 2. So here b is negative, so it changes to minus 3 over x minus 5.
Is there a way to check?
All right, so the next three say write the form of partial fraction decomposition, do not solve. So we're just setting it up with the a, b, and c. So there's some questions like this on WebAssign, so that's why I put it in the notes. So first step is what? Factor. So we got lucky in the last couple were already factored for us, but here we actually have to factor. So what are 2 factors of 9 that add to 10? 9 and 1, so we have x plus 9 and x plus 1. So when I split that up, I have x plus 9 with a on top, and then plus b over x plus 1. Now, again, it doesn't matter, you can switch it. So if I had x plus 1 first and a on top, when you work out the math, you'll get different values for a and b, but it's always going to be like that value over x plus 9. All right, so this one, all we had to do is set it up. You don't have to solve, so that's the answer. All right, so the next one looks a little bit different.
This is really good.
All right, so for the next one. So again, this one's a little bit different. When we have a binomial with an exponent, each partial fraction has to be that binomial with the exponent leading up to whatever exponent we have. So the first one's going to be x plus 1 to the first power. Then we have x plus 1 to the second power, and then x plus 1 cubed. And then a, b, and c. So that's how we would set this one up when we have a binomial with an exponent. So you have to have every degree before that one. All right, next one. So again, we do the same thing here. I have x minus 1 in my first part. What would be next?
X minus 2.
X minus 2. And then what would be the third one?
X minus 2 squared.
X minus 2 squared. So people will usually think that this is x minus 2 and x minus 2, but you have to do the x minus 2 squared. So you do every degree leading up to it. And then we have a, b, and c. So that's our answer. So example 8, again, this one we actually have to solve. So find the partial fraction decomposition. So what do I have to do first? Factor the bottom. So how do I factor this? I can take out an x, and then I'm left with x squared minus 4. Can I factor x squared minus 4? Perfect. It's the difference of 2 squares, so it factors into x plus 2, x minus 2. So I have 3 different parts of my fraction on the right. So I have x plus 2, and x minus 2. And then a, b, c. Bless you. Bless you. What do I do next?
Get the 0 on every individual thing.
Before that.
Except the numerator.
Before that. What do I multiply by? Everything that's missing. So if I have x on the bottom, I'm missing an x plus 2 and an x minus 2. So I'm going to multiply this by x plus 2, x minus 2. If I have x plus 2 on the bottom, I have to multiply this by x and x minus 2. And then in the third one, I have an x minus 2 on the bottom, so I multiply this by x and x plus 2. So we multiply by whatever's missing. Now we can set it equal to the left side. So on the left, I have x squared plus 12x plus 12.
The multiplication be in any order.
Yeah, multiplication can be in any order. And then it's equal to a times x plus 2, x minus 2, plus b times x minus 2, plus c times x plus 2. All right, so now we need to see what makes each parenthesis equal to 0. So what makes the first one here equal to 0? -2. So I have x is equal to -2. What makes this one equal to 0? 2. So x is equal to 2. What makes this one equal to 0? 0. So x is equal to 0. And then if you see, if we keep going, this one, x is going to be equal to 2 again. We already have that. This one, x is going to be equal to 0. We already have that. And then this one, x is going to be equal to -2. We already have that. So we're going to plug in all three of these. So let's start with x is equal to -2. So I have -2 squared plus 12 times -2 plus 12.
Wait, how did that simplify? If the numerator.
Okay, so then this is equal to a times -2 plus 2 times -2 minus 2 plus b times -2 times -2 minus 2 plus c times -2 times -2 plus 2. All right, so working out the left side, -2 squared is 4 minus 24 plus 12. So this would be -8. And then that's equal to, what is -2 plus 2? 0. So if this is 0, this whole thing cancels out here. Because 0 times, it doesn't matter what a is, and it doesn't matter what -2 minus 2 is because it's 0. All right, so then moving on to the b part, I have b times -2. -2 minus 2 is -4. So -2 times -4 would be +8. So this is 8b. And then in the third part, what is -2 plus 2? 0. So this cancels out also. So I'm just left with b. How do I solve for b? Divide by 8. So what does b equal? b equals -1. So let's do the same thing for when x is equal to 2. So I have 2 squared plus 12 times 2 plus 12 is equal to a times x plus 2, which x is 2. So 2 plus 2 times 2 minus 2 plus b times 2 times 2 minus 2 plus c times 2 times 2 plus 2. All right, so on the left side, 2 squared is 4 plus 24 plus 12. So this would be 30, 40? 40. What happens to a? It cancels because I have 2 minus 2, which is 0, so a goes away. What happens to b? Cancels again because I have 2 minus 2, which is 0, so b goes away. And then I'm just left with c. So 2 plus 2 would be 4. 4 times 2 is 8, so this is 8c. So 8c is equal to 40. Divide both sides by 8. So what does c equal? 5. All right, now we do the same thing, but for when x is equal to 0. So I plug in 0 to everything. So I have 0 squared plus 12 times 0 plus 12 is equal to a times 0 plus 2 times 0 minus 2 plus b times 0 times 0 minus 2 plus c times 0 times 0 plus 2. So on the left side, I get 12. This is a times 2 times negative 2. So negative 4a. The b's cancel because 0 times b is just 0. And then the c's cancel because 0 times c is 0. Divide both sides by negative 4. So what does a equal? Negative 3. So I have a, b, and c. Now I can plug it into my original blue equation up at the top. So a is negative 3, so it's negative 3 over x, plus b is negative 1, so this becomes minus 1 over x plus 2. And then c is 5, so plus 5 over x minus 2. And that's the answer. All right, so the last one. What do I need to do first? Factor the denominator. So what are two factors of negative 40 that add to negative 3? Negative 8 and positive 5. Perfect. So this is x minus 8 and x plus 5. So on top, I have a over x minus 8 plus b over x plus 5. What's next? Multiply by what's missing. So here I'm missing x plus 5. And then for b, I'm missing x minus 8. And then what should I do? Set the numerators equal to each other. So I have x plus 3 is equal to a times x plus 5 plus b times x minus 8. What's next? Find what value of x makes this 0. So what's x going to be equal to? Negative 5 and positive 8. So we plug that in. So negative 5 plus 3 is equal to a times negative 5 plus 5 plus b times negative 5 minus 8. So negative 5 plus 3 is negative 2. What's negative 5 plus 5? 0. So a goes away. So we're just left solving b. What's negative 5 minus 8? Negative 13b. Then we solve for we solve for b. So divide by negative 13. So b is equal to 2 over 13. Now we do the same thing, but for when x is 8. So I have 8 plus 3 is equal to a times 8 plus 5 plus b times 8 minus 8. So 8 plus 3 is 11. A times 8 plus 5, so 8 plus 5 would be 13. So 13a. And then 8 minus 8 is 0, so the b cancels. Divide both sides by 13. So A is equal to 11 over 13. I'm glad we did this one because it's fractions. So when we have fractions in our answer, we write it similarly, but the numerator stays on top, the denominator of our fraction goes on the bottom with the binomial that's already on the bottom. So A is 11 over 13, so this will be 11 over 13 times x minus 8. And then B is 2 over 13, so plus 2 over 13 times x plus 5. That's our answer.